want to share this with a couple engineer friends of mine. I want them to troll me on it or give me have a little fun with me. But let's use this paprika container, and as we can see, that's pretty. Nothing's going on there. If I take the lid off, or I'm using a one hand to hold the device, and one not to. If I take the lid off, it allows even more air to escape, if you will, and now it's even more pliable. But now let's put the lid on. Now imagine if this was full of air. If I could seal this. If I could, hey, everybody's popped up. Imagine if I could seal this now, and this was a steel member. So you just weld on each side, put a gauge in here, a valve, if you will, fill it with air. Now it's not compressible. That becomes more like a solid member, even though you still get the idea of the box truss, if you will. If this would be a box truss, and this helps you visualize it more with this. That it would not be compressible under the deflection loads. It would have more resistance for loads. Let's go with a soda can, for example. This is empty. We know if this was full that I wouldn't be able to compress the walls on this. I wouldn't be able to do that. So here it is, this thin aluminum can, and I'm going to do a real mock-up of it. I'm going to come up with something really thin, and I'm going to put a valve on it and put air in it. We're going to load test it, but not in this video. But you can see what you can do here. It's nothing at all. But if this was sealed and I put air in it, it's now not compressible. I'm going to work on how much of a load it can take before it fails. How much of a load before it starts to deflect. And now, on the same lines, I'd like to practice that with something like this garlic salt, just granules as opposed to air, or maybe a combination of both granules and air for its load capabilities. Right now, we have some compression going on. Obviously, if it was empty, it would just be really deflective. Now we also have the other thing of deforming the metal, shaping it to help resist. For example, this is real flexible, this capacity. If I turn it this direction, of course, now I have this ribbon here. It's going to act as a truss, or I'm sorry, as a rib to give more reinforcing to its compressing, and I'm compressing this way. And so now this one container has a hell of a load-bearing capacity from the top. Same container, same measurements. So for now, the cross-section this way, it's really, it takes easy deflection. So now what happens if you rivet? Steel is typically not ribbed like this. It's flat. What happens if you start ribbing it? Ribbing the steel and as such. And then turn it on its axis in this format. Now, as a steel, how much more compressive ability will the same amount of, it's going to take same amount of steel if you can stretch it, if you will, to get to this, not using extra steel to do it. So yes, same amount of steel, same weight, and then put the dimples in it to see what it can do this way. I want to share this with this other guy too that has access to some machines. There's again the powder now, like the chemicals there. It's still because it's still not. This is not contributing because it's not full. If it's full, then we still have the compressing problem of this. So you just can't use granules only. Soda can is filled at pressure, increased strength. That allows Coke to use less aluminum. Yes, boss. Yeah, I have watched how they put those things together. Awesome, huh? It's amazing the little bit of steel, aluminum that can make these cans. It's amazing how they stretch it. So now, this, you can see the compression of it. If I had air in here, I would not be able to compress it, yet nothing changed besides air. I just added air. I compressed air, but now it wouldn't be compressible. I want to know what it can do. And I'm going to play along with this stuff. So here's the rib of this. Obviously, it could be thinner, but they make this pretty damn thick for shape or selling, marketing, whatever it may be. So it doesn't fall out of your hand. There's other reasons they put little ribs on there. Granite. Take it for granite. Take it for granite. So the granite is, you're not going to compress it if you have it against a solid surface below. As you put pressure or a force above here, you're creating tension down the bottom. So this would be your concrete profile, sidewalks, roadways, bridges, whatever it may be. And you try to avoid the tension getting down here fully, because then it's going to crack coming back upwards. Um, this is on the tension pushing out this way and this way. This top section is pushing inwards under compression. But the tension is created down the bottom section here, pushing outwards. If you can confine this so it cannot push outwards, you also get greater strength if you pin it. But you also get problems here and here on the ends, because the forces still want to work their way out towards the pin then. And the pinned section will want to crush. And I'll show you that with some bridges, how they're on rollers. And then hopefully now you understand why a roller as opposed to pinned. And so that, can it be variable though? Can you have this now as a signal? So you sort of pin it and you put testers over here. So when your bridge gets too much of a load here, it starts putting pressure, excessive pressure down here on this pin, then sending an alarm off to wherever it goes off to, saying this bridge is being overloaded at this point. I mention that because if you guys saw the bus video, which I'll show you this bus video, not in this one, I'll go live and videotape again just in a moment. But we're going to watch a bus go across this bridge in Arkansas. That is crazy what it does to the members. All right, I'm going to terminate the video. I just want to share that with you guys.